Right, so what I'll get the light now in a second. What we're going to have a look at in the first lesson, linear equations. Is that okay if I leave it like this? Yeah? You can see? Yeah. Okay, so really we're just covering a little bit of basics here. What's this called here? If I have something like this, what's this? Yeah. This is an XY plane, or you could call it like an XY graph or something like this, or just well, really just XY graph, XY plane, XY plot. These are all the different words for it. If you want to get fancy and use more fancy vocabulary, you can see it, I have it there. Cartesian plane, or graph or plot. But that's just being fancy, okay? We'll just call it an XY graph. Now I hope you remember this from middle school. So don't forget, we call this one the X, and this one is called the Y. Yes, and the vocabulary here, say it again.
Y-axis.
Yeah, this is the X-axis, and this is the Y-axis. And somebody else. What's this called? Somebody else this time. Yep.
Origin.
Origin, yeah. Okay? So it's really, I'm just doing, again, like with the physics, I'm just covering some basic vocabulary so we can start. Any other vocabulary you know that goes with this? More vocabulary? Well, what's this called? Like this? Yeah, true, line, yeah. Not true, line. But I mean, yeah, this is horizontal and this is vertical. Yeah. But don't worry about that.
The next question is the horizontal axis.
Yeah, you'll hear it a lot in physics. True. So that's just basic vocabulary. Okay? Right, now what about this? If I write something like this, what's this called?
Point.
Yeah, this is a point. And you draw it like, for example here, let's call this point A. So here is A here. And again, I'm sure you remember this from middle school, but if it's been a while, I'll refresh your memory. You go out X here, and you go up Y here. Just in case somebody forgot. What is the X called, and what is the, whoops, let me try that again. What is the X called? We don't call it the X part. What do we call it? Does anybody know? We call this the, no, that's okay. X coordinate. Yeah. That's its name. The X coordinate and the Y coordinate. Okay, so basic vocabulary. Can I scroll down? Do you have these words? I can feel like somebody's translating. No? No translation? you got there?
My nose.
What have you got? Show me. What have you got? I can't see. No, show me. What have you got? Ah, let me see. Kitchen.
No.
I want to see what you're looking at.
No.
Don't be shy.
Yes, I'm shy.
Okay, fine. If you don't know, just ask. Yeah. I lost my train of thought. What was I saying? X coordinate, Y coordinate. Okay, I was going to move on to the next part. Do you have this taken down? Do you have these words? You need these words. They're important words. You have them? Or do you know them? That's fine. What words? Tell me.
I just didn't know.
Not anymore.
Not anymore? Good. Okay. Can I go down?
Yeah.
Yeah? Okay. Now, this is the equation of the line. So what I mean by that, this here is actually going to make a line on your graph. So some more vocabulary now. What we call it equation of the line, but there's another word for it, an adjective. Yeah, I'll give you a hand here. Adjective equation. So there's a word I can put here that means line. In other words, my question is this: if line is the noun, what's the adjective?
Line.
Go on, say it again.
Line.
Spell? Just L-I-N-E like this?
I-N-G. L-I-N-I-N-G.
Oh, I see. Linen? No. Good guess. Good. Not this. Anyone know the adjective? Linear. Yeah, it's linear. L-I-N-E-A-R. That's the adjective. So we can call this equation of the line, or we can call it linear equation. Okay, so linear is the adjective. Line is the noun. What else? Okay, I can scroll down. Well, actually, I need to talk a little bit more about this, but I can go down. Yeah. So we have y equals mx plus c. So in fact, each part of this has a name. So this has a name, and this has a name. So this has a name, and this has a name. So does anybody actually know the names? Don't say M. I know it's M, but it has another name.
Gradient.
Gradient is one, yep. And there's another word as well. Does anybody know it? True, but I'm just looking for one word though. Gradient is what is said in the US and the UK. In Ireland, sometimes you will hear me say slope instead.
Slope?
Yeah. And the sea has a name as well. Does anybody know it? Yeah, that's it. This is called the intersect. Or maybe to be more precise, it's called the y-intercept. So yes, you need this word, and this word, and this word. You got those words? You wrote them down? Yeah? So for this lesson, I'm assuming you already have seen this before, because really this is middle school, right? Now if it's been a while, that's okay, but I hope everybody has seen this before. Would that be right? Maybe a long time ago, but I hope you saw it at least once in your life. Twice now, okay? I'll do a little bit more vocabulary, just one more piece of vocabulary, and then we'll start looking at some questions and problems. So the last piece of vocabulary I just want to do with you before moving on. Here is my x-axis, here is my y-axis, here is point A, here is point B, and this point here, which I'll call it M, is in the middle, and this has a special name. Does anybody know its name? Yeah, this is called the midpoint of A and B. That's what the M is called. So if I say point, mid meaning just middle or center, yeah. Okay. So we have some basic vocabulary. Now let's look at some basic formulas. I can scroll down? Yep. So let's have a look at, you know what? Let's be fancy today. What do I want to do? I don't know. Hang on. The equation is represented by a line on the xy plane. So for example, e.g., that's almost a line. There's x, there's y, there's my line, and let's say this is y equals 3x plus 1. And let's say here this is, I don't know, say this here is 1, this here is 2, whatever, and then here, I'm not drawing this accurately, this is 1, this is 2, this is 3, for example. And what's over here? What's here? Minus 1, minus 2, and so on. Okay. So my question is, what happens if I make this number bigger? So for example, what happens if I change this to y equals, let's say, 4x plus 1? What happens to this graph? How does it change? The line will... Very good, yes, very good. The line will move up to the north. So, I'll show you this actually in a graph here. So y equals 3x plus 1. Right, so let's see what happens. Watch, y equals 4x plus 1. Let me just move this a bit. Whoa. That's not good. Hang on, I want to... No, not that one. The other one. There we go. Yeah, okay. So let me draw this new line now. So can you see it in blue? It's moved up. Yeah. What would happen if it was, let's say, negative? Yes, the line would go down. Okay. Yeah. It's not that entertaining, is it? No? Y equals, let's do this one. What happens if the slope is 0?
Why is the straight line?
Now they're all straight lines.
No,
It will be y is equal to 1.
Yeah, but what type of drawing will I get? Go on, continue. I think you have it. One sec, I think you have it.
horizontal.
It's a horizontal line here. If you draw this, you should get
Horizontal line at 1.
horizontal line at 1, straight across. So in other words, the M tells me which way the line is pointing. You know, it's positive, it's going up, negative, it's going down, and 0, flat, horizontal.
I'm not able to read the software name actually. Derive?
Derive, yeah. Now, what happens if I change here, this number? So actually, let me draw it in green here. That would move the line up. Okay, and then what happens if I change this number now? Let's say I have y equals 3x plus 2. What happens here? It will move up. So instead of being at 1 here, it will be at 2. Let's look at our super graphics program. Alright, there's the first one. And let's have a look. So you see it's moved up. And then what about...
It's going to be down.
Yeah, can you picture where this might be?
Maybe
Further down. Still parallel, very good, yeah, parallel. So somebody tell me this. How can I make my line completely vertical?
y is equal to 0.
Like that. Y equals 0? No.
X is equal to 0.
Yeah, so for example, if you have something like this.
It is straight. And y
It doesn't really work in the program anyways. Watch this. Y equals 3x, I don't know, plus 1. Okay. Y equals 30x plus 1. Yes? Y equals 3000x plus 1. Can you see it in green? It almost looks vertical, doesn't it?
Yeah.
Let's zoom in. Almost. We can't even see. Anyway, the point I'm trying to make is when the line is completely vertical, what do you think the slope is? Now, what do you think the slope is if the line is completely vertical? What do you think it is? Any ideas? Have a look here at what I was doing. You can't really see. So the blue line, the slope is 3. The black line, the slope is 30. The green line, the slope is 3000. So what happens when I make the slope bigger? What happens to the line? It continues going north. So if I wanted to be perfectly vertical, what do you think the slope should be? Now what should the slope be? 1? No. What's happening to the slope? 330, 3000. What's happening? It's getting bigger, isn't it?
Yeah.
So slope gets bigger, it goes up. So if I want this, what do you think it should be? Nobody wants to have a guess? You're all too shy. It's the first day, yeah? No, my question is what should the slope be?
4,000?
Thank you for an answer. Not this, but you've got the right idea. Nobody wants to say it, no? Nobody wants to have a guess. I'll put you out of your misery. It's okay. So here, the slope is 0. Here, the slope is positive. Here, the slope is negative. And lastly, this one here, the slope is...
1
Nope.
plus minus.
Of course. Infinite. Yeah. That's because when I say the slope equals, let's say, 3, that's actually 3 over 1, which means you go out 1 and you go up 3. So if I say the slope is 100, that is actually 100 over 1, which means you go out 1 and up 100. Okay, so that's why for this one you need this. The reason for the minus is if you want this one going down. Anyway, I just want you to understand how the slope changes the shape. Bigger slope goes up more. Negative slope goes down. No slope, horizontal. And if I want vertical, infinite slope. Yeah? Okay.
But every line does not end.
Correct.
Yeah.
Yeah. True. Okay. There is a way to calculate the slope. So this is our first formula. If you have 2 points, x1, y1, x2, y2, and you want to calculate the slope, give me a full sentence. Hang on, I see somebody might know it. Yeah? Anybody want to give it to me if they know it? You know it?
x1 minus x2
Go on, continue.
plus y1 minus y2.
You're so very close.
So
It's y2 minus y1 over x2 minus x1. So the y over the x. Okay, so please note this. Okay, still a bit more vocabulary, but I promise this is the last piece of vocabulary, and then we can do some questions. Can I scroll down? Yeah. So last piece of vocabulary. Well, maybe before I just do the vocabulary here. The slope, n, positive, negative, or 0? In this example, negative. The intercept, C, positive, negative, or 0? Positive, good, okay. This here is actually the C, and it's called the y-intercept, as you know. But this point here has a special name, too. Does anybody know the name of this point? Yes, and its special name is? Has a special name? Oh, come on, somebody must know this. I'll give you a little clue. Starts with 4. What? Go on. Root. Doesn't count if it's after. Okay, so we call this the root. many points do you need to make a line? You need 2 points to make a line. These are usually the 2 points we use to make a line. So you need 2 points to make a line. Yeah? 2 points. If you have 1 point, you can't make the line. And if you have 3 points, you can. But you only need 2. Yeah? Right, examples. Okay, so some of the vocabulary is new, some of the vocabulary is old, but for this, I want you to write everything down, okay? So, I don't care who you are, write down what I'm writing down, okay? Okay, represent 4, 8, oops, I'll make that 8 a bit better. Represent the point 4, 8 on a XY graph. Okay, so this is our first example we're going to do. So this is just to get us started. Okay, so on the X, how many points do I need? How far do I need to go? To 4, yeah, so let's go like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. On the Y, where do I have to go? 8. Ah, come on, there we go. 2, 4, 6, 8, 10. So my point 4, 8 will be 1, 2, 3, 4. And then 1, 2, 3, 4, it goes up to 8. So here's my answer here. Here is the point 4, 8. And if it was negative, we go left or we go down. Question. You see here, this is 2 units, and this here is, for example, 1 unit. Do they need to be the same size? For example, if this was 1 centimeter, can this also be 1 centimeter? No. Or does it need to be 2 centimeters? Or less than 1 centimeter? Like, I mean, if this is 1 centimeter for 2, and this is 1 centimeter, is my graph right or wrong? No. That's my question. Have I done the scale correctly or incorrectly?
No.
You think it's wrong?
Yeah.
In fact, it's right.
Yeah.
So, yes.
Yeah.
It doesn't matter if the X and the Y are different. It doesn't matter. It only matters if you keep the X the same. So, for example, if 1 centimeter is 1, then it needs to be 1 all through. On the y-axis, if 1 centimeter is 2, then that's okay, as long as you keep it 2. Okay? So you don't need the X and the Y to be the same. The X needs to be the same for itself, and the Y for itself. But they don't need to be the same together. Okay? So some students get confused about this. They think it has to be the same. It doesn't. They can be different. This is not a problem. Okay? And in fact, if you look here, back to my graphing program, let's do a silly example, y equals x. In fact, the graphing program even lets me change it. So if you look here, I can go 5, 10, 15, whereas here I go 1, 2, 3. So it really doesn't matter once you keep it the same each way. Okay, next example. What is the midpoint of, and I'll tell you what, I'll draw them roughly for you, very, very roughly. 4, 8, which we'll put here, and then -2, -8, which I'll put here. So does anybody have any ideas on how I could find the midpoint? The point that's in the middle. How can I find this? Yeah, you have an idea for how to help you?
8
Yeah?
minus bracket minus 8.
Nope. Almost. Not quite that. I'll help you out. If this is x1, y1, and this is x2, y2, how do I get the middle for the x?
X plus x2
Divided by 2. And then for the y, it's the same. y1 plus y2 divided by 2. This is how you get the middle of a number. So the middle of 4 and -2 would be 4 minus 2 over 2. And the middle of 8 and -8 would be 8 minus 8 over 2. Yes.
8 minus 9.
No, that's what Fahad says.
Wait. See.
Trust me,
Why?
I know what I'm doing.
You,
Trust me.
for the midpoint,
Watch carefully, wait. 4 plus -2 over 2. 8 plus -8 over 2. Yeah, Trinity College don't hand out degrees to anybody. Okay, so it's alright. 2 over 2, and here? This one? 0 over 2. So what do I get here? 1 and 0.
because when you wrote the first time the formula M, I thought that you were saying for midpoint.
Nope, that's for the slope. Oh yes, M for midpoint. Yes.
Yeah.
Okay, do we have this one? Yeah? Next example. Did you write this down?
Yeah.
Okay. Example. Express 6x plus 7y plus 3 equals 0 in the form y equals mx plus c. You've seen this one before, huh? So what I want you to do here is to rewrite so that you have y on the left. Let's see if you know the English for this. Does anybody know how to describe this in English? It's not quite solved because you're not getting an answer. Yeah, go on, continue.
First equation.
Yeah, no wait a sec, yeah, go on. You have the right verb, yeah, express. No. Any other suggestions? No, okay. So, another way to say this is make y. We go, yeah. I knew once I had to start, someone would get it. So make y the subject is what you're doing here. Okay. So, what do I do first? What do I do first?
Take 6x to the side.
Yeah, take 6x over here, and also I could take 3 over.
6x minus 3.
Yeah, so you get 7y equals minus 6x minus 3, and finally?
Divide by 10.
Yeah.
Everything divided by 10.
Divide by 7. So my answer is y equals minus 6 over 7x minus 3 over 7. So yes, that was fun, of course, but why bother doing this? What was the point? Why do I care about doing this?
Because mostly we need to make a y check
Yeah, but why?
to make the line up.
True. And when it's written like this, I can compare. What's the m for this line?
Gradient slope.
Yeah, and in this example, what's the m? Minus 6 over 7. And what's the c? Minus 3 over 7. Do you know that here? No, you can't really see it. But when you rewrite it like this, you can see it. You can see what the m is and you can see what the c is. Okay, next example. Simple. Okay, here I would like to check if this point is on this line. So I would like to know, is this point on the line or is it off the line? Anybody have any ideas on how to do that? Yes?
You can
Yes, she hasn't answered yet. Go ahead. Yeah? Continue, say again. I couldn't hear you. Yeah? Yeah, so I put the point in. So, what do I do with this? Yeah, it goes here, yeah? And then what about this? Into the y. Yes. If it equals the same, it's on the line. If it's not equal, it's not on the line. So let's see. Minus 25 equals 4 times minus 7 plus 2. Minus 25 equals minus 28 plus 2. Minus 25 equals? Yeah? So is this on or off the line? Very good. This is off the line. So it's not this one, it's actually like this. It's off the line. Okay, next example. Oh, come on. Next example. Draw So, after 45 minutes, we're about ready to draw our first line. Congratulations. So what do you think I need to do first here before I can draw this line? Yeah, before that? Make y the subject. So let's do that. Make y the subject. So I have 7y equals minus 4x plus 3. Y equals minus 4 over 7, x plus 3 over 7. That's really good, because I can know what the y-intercept is. What is the y-intercept here?
3 over 7.
It's 3 over 7. So 3 over 7 would be around about here. This is the y-intercept. Another way you can think about it is, if you let x equal 0, what will y equal? if x is 0. What's y? It will be 3 over 7. So, you know, this is like our first point, 0 and 3 over 7. But how many points do we need to draw this line? 2. So what I would like to do is find out where the root is. How could I do that? How could I find where the root is?
You can take the y is equal to 0.
Yeah, I could say let y equal 0. This will give me the root here. So, I have 0 equals minus 4 over 7x plus 3 over 7. You see what I did? I just made the y 0. Yeah, that's me. That means hurry up. So the y equals 0. I can find the x now. What should I do next to help me find the x here?
Make x something.
Yeah, well, just bring this over here. So I get 4 over 7x equals 3 over 7. What can I do next? Keep going, yes, I should always do that. I should always keep going, never give up. But what should I do in this example?
7 into 2 or 7.
Divide both sides by 7.
Thank you. Multiply both sides by 7, so the 7's go. So now I have 4x equals 3. Then what do I do? Very good.
3 over 4.
X equals 3 over 4. And y we said was 0. So here is the root. The root is 3 over 4 and 0. So this is what the line looks like. It goes through these 2 points. Okay. Scroll down. Yep. Example. Now I won't draw it because you have to draw it in here, in your book. You see the first picture? Yeah? I want the equation of this line. So if I want the line, how many points do I need?
2.
I need 2 points. So let's find 2 points. What about that first point there, the root? What's the root of this first graph?
Minus 2, 0.
Yeah, minus 2, 0. Very good. And what about the y-intercept? What's the second point?
4, 0.
0, 4. If I want the equation of a line, I need to find the m and the c. How can I find the m?
To find the formula.
Yes, I can just use my formula, remember? So, what's the formula? M equals y2 minus y1 over x2 minus x1. So here would be 4 over 2, so it's 2. Now, next question. How can I find the c?
To put this value and find, make the c subject and find the value.
Normally, but I don't need to in this example.
This is derivative.
Very good. What is the c?
4.
You can see the c is 4. I don't even need to do any work. It's 4. Two more examples and we'll finish. And the second example is very short. So the first example, one of 2 now. Okay. As you can see, I'm not even writing sentences anymore to try and speed things up. Can I scroll down now? I'll give you about 5 seconds. Ding. You can copy it from someone in class. So in this example here, I have the point, for example, 1 minus 1, and here I have the point 6, 9, and I want the equation of this line. So it's like the last one. How can I find the n? y2 minus y2 minus y1 over x2 minus x1. So in this example it will be 10 over 5, which is 2. Now the problem in this example is, what's the c? We can't see it on the graph, can we? No. Any ideas on how to find c? I know you know it now, Fahad. Yes, what is it?
Put both values in the equation and solve it.
Almost. Half right.
Find c.
Half right. No. You did too much work. If you want to find c, you need to use one of these points. It doesn't matter which one. Pick a point. Which point? Which one will we use? Let's use 6, 9, since there's no minus in it. Yep. So, if you want to find c, what you do, you say,
By 1 point.
by using 1 point, yeah. Y equals mx plus c. I'll use this point. Doesn't matter which point. I just use 1 point. So you get 9 equals 2 times 6 plus c. We know that this must be true. Why? Because it's a point on the line. And remember earlier we said if it's equal, it's on the line, and if it's not equal, it's not on the line. So here I get 9 equals 12 plus c. What's c? Minus 3. I can put this back in here, and I get y equals 2x minus 3. Yeah.
Here it says find the equation of each line. So, and the answer of the question, where is it?
Funny enough, it's on the next page.
Okay.
If you look at the next page. Your math book would be no good to you if I didn't give you answers also. So the answers are on the next page. Yeah? We'll have one more example. Can I scroll down? Yep. Example. I want the horizontal line at 17.6, and also another example, I want the vertical line at 1984. And the smart students will realise what your teacher's birthday is if you look carefully at this example. Yep.
17 June
Yes.
1984.
Correct. Keep that in mind come June, okay?
Won't be there.
Except gifts by the post. It's okay. Right. So we haven't talked about this, but we'll finish with this example. Here is the point 17.6, and I want the equation of the horizontal line here. Does anybody know the equation of this line? In fact, you can see it straight away. What's the m? What's the m? 0. So y equals 0x plus c. What's the c? 6. So the equation of the line is y equals 6. In fact, it's y equals 0x plus 6. We can forget about the 0. So it's just y equals 6. And then here, let me put it over here, 1984. This one is a little bit more difficult, but you could probably guess the answer. If I want the equation of this line,
Y is 0.
what's this one?
Y is 0. X is equal to
This one is x equals 19. Now if you think about it, it makes perfect sense. Here x is 19. Here x is 19. Here x is 19. Everywhere x is always 19. So that's why for the vertical lines it's just x equals. So in other words, for horizontal lines they are like this, y equals a number. And for vertical lines it is x equals a number. And if it's in between, it's y equals mx plus c. Okay, so I think that point is worth saying again. So if I have a line like this, what's the equation of it? No, I use a different colour. Y equals a number. If I have a line like this, what's the equation? X equals some number. And a line in between, a line like this, y equals mx plus c. So 99% of the time you're looking at this, but 1% of the time you're looking at one of these strange lines, horizontal and vertical. Homework. So, of course, you don't need to do all the questions. But let me tell you what questions you do need to do. So, if you can just circle them. Okay? So, in number 1, do B and C. B and C.
Number 1,
B and C in number 1. You got that? Number 2, B and C is okay. Get B and C in number 2. Number 3, B and C again. Number 4, yes, B and C is okay. Number 5. Number 5, I want you to do B and D. B and D. 6, A and B, no choice. 7, let's do it again, for kicks. 7, B and C. 8, C and D. 9, have a guess? Yeah, A and B.
No one.
Huh?
No and don't anything else.
In which one?
No.
9?
No. No nine.
There is a 9.
No nine.
There is a 9 right there. A and B, 9.
I don't want to see.
Sorry, you saw. Okay, so I will check these in our next class, which is tomorrow. Well, some people have the class tomorrow, and your timetable is called extra math. I think the people who should go to that got an email today. Anyway, look, if you want to go to it, if you feel you need to go to it, go to it.
What's the what?
The extra math class tomorrow. On your timetable it says extra math.
So it's not compulsory.
It's not. It's optional for everybody, but some people, I think they got an email saying they should go. If you didn't get one, then it's optional. Okay?
No more laptop.
Sorry, no, this wasn't the last class. We'll have more math classes. Yeah? What are you asking me? What's your question?
No.
No. Okay. So I hope to see some of you at 10 o'clock, I think the class is. I don't expect to see all of you, but I do hope to see some of you. And some of you I hope not to see. Alright.